All right, the next phase in solving a compound inequality is, well, actually solving it. So we have this. 5 is less than 2 times the quantity of x plus 3 minus 5 is less than or equal to 7. There's a lot of stuff going on here. But notice that we do have two inequalities. So this is a compound inequality. As soon as you see more than one little inequality symbol, that means you have a compound inequality. Now, how we solve this, at the most basic level, it's the same way we solve any other equation. You'll notice that there's some distributing I can do and some combining of like terms. So before we start dealing with any of the actual inequality typeness of this equation, or inequality, I'm going to do what I usually would do it. So distribute the 2, and then so I have 5 is less than 2x plus 6 plus a negative 5, because I can change that, is less than or equal to 7. And then combine like terms here, the 6 and the negative 5. So I have 5 is less than 2x plus 1, because 6 plus negative 5 is 1, or 6 minus 5 is 1, is less than or equal to 7. Okay, so now what? Now that I've done that, now I can treat this just like I treated my previous example here, where I had this compound inequality, and I looked at, or I thought about splitting it up into two different inequalities, two different inequality statements. What I have here is 5 is less than 2x plus 1 is less than or equal to 7. Be careful, this plus 1, this is all one expression. That goes in parentheses. This is all one group. I can't, for example, this is a mistake that I see people make sometimes. I'm not going to interpret that as 5 is less than 2x, and then 1 is less than or equal to 7. This is all one solid group. It needs to be grouped together. What I can do, though, is 5 is less than 2x plus 1, and 2x plus 1 is less than or equal to 7. This is an appropriate interpretation. This is what, or these two separate inequalities is what this compound inequality means. That's how we can interpret that compound inequality. And the nice thing about breaking it down like this is now I just have two inequalities, two simple, straightforward inequalities that I can solve. And so I'll go ahead and do that. Make this easier to move down. So the one on the left here, 5 is less than 2x plus 1. I'll subtract the 1 from both sides. I get 4 is less than 2x. Divide both sides by 2. And I get 2 is less than x. Or if you prefer, x is greater than 2. They mean the same thing. And that might make it a little bit easier to graph it. And then over here on the right, I subtract 1 again. I get 2x is less than or equal to 6. And then, again, divide both sides by 2. And I get x is less than or equal to 3. Now keep in mind, this does work because we have these two inequalities and there's no or. It is implied, just like it was before, that there's an and between those two things. So when I describe my solution, what I'll say is that x is greater than 2 and x is less than or equal to 3. Or to use the more standard notation here, where I have 2 less than x, and then x less than or equal to 3, I could just say 2 less than x less than or equal to 3. And that makes it a little bit easier to graph, because now, when I go to make my number line, so 0, 1, 2, 3, 4, 5, I know that I'm going to have an open circle at 2, because 2 is a boundary, but I'm not including it. I'm going to have a closed circle at 3, because 3 is the other boundary, and I am including that. And then I connect them. So that's my answer, and that's my graph. And you can write the answer in either of these two ways. Both of them are acceptable. So that's when we have an and probability. Solving an or probability is the same setup, and honestly, it's even a little bit easier because it's already set up for you. It's technically a compound inequality because this is all one statement, but it's already broken up. And you pretty much know immediately what we're going to be doing. We're going to be subtracting 4 from both sides here. Minus 4, minus 4. I get negative 3x is greater than 12. And then subtracting 4 from both sides over here. So I get negative 3x is less than negative 9. Then I divide both sides by negative 3 over here. and I get x is less than -4. You've learned this before, and your teacher will make a big point about this in class. We're dividing by a negative. Make sure that when you divide by a negative, you change the direction of the inequality. Same thing over here. When I'm dividing by a -3, I get x is greater than +3. So be careful about that. Then when we go to graph it, we have two different inequalities again. And this is an OR. So this would be one way of writing my solution. I can't write these together without saying OR, not like I had with previous example. I have to leave the OR in there because, again, we can't have a number that's both less than -4 and greater than 3, and so we just leave it like that with a little OR statement. And so when we graph it, I'm going to need a little bit more space, so I have -5, -4. I'm going to cheat a little bit and not actually label everything, so -3, -2, -1, 0, 1, 2, 3, and then that's 4 over there. And so I have an open circle on the -4 with an arrow going to the left, and I have an open circle on the 3 with an arrow going to the right. And so that's my answer.